2025 A-Level Combined Mathematics Paper 1 Part A question number 7, the differentiation question. This question says, let C be the curve given parametrically by x equals e to the power of t minus 2 times e to the power of minus t and y equals 2 times e to the power of 3 plus e to the power of minus t for t element of the real numbers. So this means that t is some element of the real numbers, it can be any element of the real numbers, and for a particular value of t, there's a corresponding point x comma y that is on this curve C. Now given this, we are asked to first show that dy by dx, the derivative of y with respect to x, is given parametrically in terms of t as 2 times e to the power of 2t minus 1 divided by e to the power of t plus 2. And then we are asked to find the gradient of the tangent to the curve C at the point on it corresponding to x equals 1. So here note, we are given the x value. We are not given the value of t. So in this case, we are going to have to do some kind of reverse engineering to get the value of t corresponding to x that we can then substitute into dy by dx in order to get the actual gradient of the curve. So let's start off. To start, we are going to need to find dx by dt and dy by dt. The reason is that then if we find those, we can use the chain rule to substitute dy by dx as dy by dt times dt by dx. So let's go. To start off, let's write down x equals e to the power of t minus 2 times e to the power of minus t. Now let's take the derivative with respect to t. So we do dx by dt. So when taking dx by dt, we can see the first term e to the power of t is going to remain as e to the power of t, since the derivative of e to the power of anything with respect to that variable is going to be e to the power of t. And then this minus 2 times e to the power of minus t is going to become plus 2 times e to the power of minus t. The reason is the derivative of e to the power of minus t is going to be minus e to the power of minus t, and that when multiplied by minus 2 is going to become plus 2 times e to the power of minus t. So this is dx by dt. Let's now find dy by dt. To do that, let's write down y equals 2 times e to the power of t plus e to the power of minus t. Now the first part, if you do dy by dt, the first part 2 times e to the power of t is going to remain as 2 times e to the power of t, since the derivative of e to the power of t is e to the power of t, and that multiplied by 2 is going to remain as 2 times e to the power of t. Now for the next bit, the plus e to the power of minus t is actually going to become minus e to the power of minus t, since the derivative of e to the power of minus t is minus e to the power of minus t, and when you add that to this thing, it's going to become minus e to the power of minus t. So therefore, this is the value of dx by dt and this is the value of dy by dt. Now we can use the chain rule to find dy by dt, dy by dx rather. To do that, we do dy by dx is equal to dy by dt multiplied by dt by dx. Or I could alternatively do multiplied by 1 over dx by dt, but for now we'll just do multiplied by dt by dx. Now dy by dt we can directly substitute. It is this part over here, 2 times e to the power of t minus e to the power of minus t. So I'll do that, 2 times e to the power of t minus e to the power of minus t. And as for dt by dx is equal to 1 divided by dx by dt. So we need to basically divide by this thing right here, e to the power of t plus 2 times e to the power of minus t. So we'll divide by that, we'll divide by e to the power of t plus 2 times e to the power of minus t. Now you'll note, while this is dy by dx, this expression that we have here does not exactly match this expression here. And the reason for that is that this expression here has the top and bottom multiplied by e to the power of t. So if we ourselves do that, if we take this thing right here and we multiply the top and bottom by e to the power of t, we can see at the top, the first part is going to be 2 times e to the power of t times e to the power of t, which is going to be 2 times e to the power of t squared, which is going to be 2 times e to the power of 2t, since we have the index rule simplification of e to the power of t squared being equal to e to the power of 2t. So if you write that down, the first part is going to be 2 times e to the power of 2t. The next bit is going to be minus e to the power of minus t times e to the power of t, which is going to be 1. And then divide by e to the power of t times e to the power of t, or e to the power of t squared, which once again by index rules is going to become e to the power of 2t. And then plus 2 times e to the power of minus t times e to the power of t, which is just going to be 2, since e to the power of t times e to the power of minus t is going to be 1. So therefore we can see we have solved this bit of the question and we have found dy by dx in terms of t, and we can see it's exactly what we would expect up here. So we have solved the first part of the question. Now to solve the next part of the question, we need to find the tangent to the curve C at the point corresponding to x equals 1, which means we need to find dy by dx at x equals 1. The problem is that dy by dx is in terms of t and not in terms of x. So in order to find dy by dx, we need to first find the corresponding value of t corresponding to x equals 1. In order to do that, what we're going to be doing is using this equation here, which is x given parametrically in terms of t. So what we're going to do is to find the value of t corresponding to that value of x by considering the value of t from this equation that will happen when x is equal to 1. So we're going to consider down here for x equals 1 what the value of t is going to be. So for x equals 1, we can see that this is going to turn into 1 equals e to the power of t minus 2 times e to the power of minus t. Now, if I simplify this down a little bit and rearrange it, I can see that we can get e to the power of t minus 1 minus 2 times e to the power of minus t equals 0. If I just take this minus 1 to the other side and equate it over to 0. So if I do that, we can see we now have this equation here. Now note what happens if I multiply everything in this equation by e to the power of t. The first term is going to become e to the power of t squared. The second term is going to become minus e to the power of t. And the third term is going to become minus 2 times e to the power of minus t times e to the power of t, which is going to become minus 2 times 1, since e to the power of minus t times e to the power of t is going to be 1. And this is going to be equal to 0, since e to the power of t times 0 is going to be 0. So now we have this. Note that this thing right here that we have is a quadratic equation in terms of e to the power of t. And note that if we factorize it, we can get the two factors e to the power of t plus 1 and e to the power of t minus 2. You can see if you expand this factorization, it does in fact give you this thing here. So now this is equal to 0, and this gives us two solutions for e to the power of t. Either we could have that e to the power of t plus 1 is equal to 0, or e to the power of t minus 2 is equal to 0. So which of these is correct? If we go up here, we'll realize that t is an element of the real numbers, and due to that, e to the power of t can only be a positive number. Now this solution here, e to the power of t plus 1 equals 0, can only occur if e to the power of t is equal to minus 1. As we know, e to the power of t minus 1 has the solution e to the power of I pi equals minus 1. Now note, this would mean that t would be equal to I pi, and since I pi is not an element of the real numbers, we can conclude that this solution here, e to the power of I pi equals negative 1, is not going to be the valid solution for this thing, meaning that this thing can be discarded, meaning that e to the power of t minus 2 is equal to 0. Now for our logic on why we can get rid of this part, we need to write something. In order to write something, we could probably write something like e to the power of t is not equal to minus 1 as t is an element of the real numbers. I think that this is sufficient explanation for why we can eliminate e to the power of t plus 1 equals 0. So now that we've done that, we have e to the power of t minus 2 equals 0. Now this solution here leads us over here to e to the power of t being equal to 2, which means that if we take the natural logarithm of both sides, t is equal to the natural logarithm of 2. So now we have the corresponding value of t corresponding to the value of x equals 1. Now what we have to do is to substitute that value of t into dy by dx in order to find the gradient of the tangent to the curve at the point corresponding to x equals 1. So we can say therefore gradient of, let's say, tangent to c at x equals 1 is equal to the value of dy by dx at this value of t, which is t equals natural logarithm of 2. So we can say t equals ln 2. And finally, the last thing we need to do is to actually substitute that into the expression and get our final answer. So if we do that, we can see this is equal to, if we substitute natural logarithm of 2 into this part here, we can see we get 2 times e to the power of 2 times the natural logarithm of 2 minus 1 divided by e to the power of 2 times the natural logarithm of 2 plus 2. Now if we substitute in, we can see that 2 times e to the power of 2 times natural logarithm of 2 is going to be e to the power of natural logarithm of 2 to the power of 2, which is going to be e to the power of natural logarithm of 2, which is 2 squared, which is going to be 4 times 2, which is 8. So we have 8 minus 1 divided by e to the power of 2 times natural logarithm of 2, which is going to be e to the power of natural logarithm of 2 squared, which is going to be 2 squared, which is going to be 4 plus 2. So we can write 4 plus 2, which is going to be 7 over 6. So the answer is 7/6. Now we got a little bit tied with space, but since you can of course always make your handwriting smaller like I did, we are fine. You should probably take a little bit less space than what I've written here for this part in order to have more space to write this final answer. But that of course falls under space management, which you yourself have to figure out by yourself. Now it could be argued that I wrote this part here a little bit bigger than needed and I could have written it in maybe 2 lines, but I'm writing with this pen here, so we have to excuse that. So you yourself need to manage your space and write all of these steps in this order in order to get the final answer of 7 divided by 6. So now let's go over the marks that you're going to be awarded for this kind of question. At the start, for finding dx by dt, like this, by writing first x and then finding dx by dt, you're going to get 5 marks. Similarly, for finding y and dy by dt, you're going to get another 5 marks. And then, for applying the chain rule like this and then finding dy by dx in terms of this part here and writing that dy by dx is equal to dy by dt times dt by dx, you're going to get another 5 marks. After this point, when you realize that 4x equals 1, there's going to be a particular value of t that you're going to have to find, and then you do all of this work and you find that that value of t is equal to natural logarithm of 2. For all of this work and finding that t equals ln of 2, you're going to get 5 marks. And then finally, substituting that value of ln of 2 into this and realizing that the gradient of the tangent to c at x equals 1 is going to be dy by dx at t equals natural logarithm of 2, substituting and find the final answer of 7 divided by 6, you're going to get another 5 marks. So you can see you're going to have to first realize that the parametric is going to have to be solved like this by finding dx by dt, dy by dt, and then using the chain rule. For that you get 15 marks. And then for the second part, when you realize that x equals 1 is going to have a corresponding value of t, and you're going to have to find that value of t, and then finding that value of t is going to get you some marks, and then finally substituting that into the expression for dy by dx and finding the final answer is going to get you another 5 marks. So that's going to be all for this video. I hope you enjoyed. If you have any feedback, post them in the comments down below. Thank you for watching and goodbye.